All right, we are streaming on YouTube. Oh, hey, someone from Bangkok. I love Bangkok. I spent a year or two in Thailand. Oh my God, you're Gen X. Damn, the only person older than me here. Welcome, welcome. All right, so we'll wait for the room to fill up a bit. I'm already happy seeing so many, well, I want to say faces, but it's not faces, it's just names. So happy to see so many random names here that I don't think I've seen before. Yeah, we'll give it 5 minutes, wait for it all to fill up. Keep saying we need background music for these kinds of things. So if anyone is good at humming or whistling, or you've got a guitar or a ukulele, in hell, I'll take a kazoo or a triangle. We have low standards here. Oh, hey, Joanne.
Hello.
So yeah, where is everyone, by the way? I mean, right now, Sophia and myself, we're in Berlin. Joanne, you're in Barcelona.
Yes.
And Raphael?
Toulouse, in the south of France.
Ah, Toulouse. And Akshat?
Sorry, can you repeat? I couldn't hear properly.
Whereabouts are you in the world?
I'm India.
Ah, which bit? It's a big place.
I'm currently in Bihar.
Okay, nice.
Yeah.
Cool. Oh, samples, and you found problems. Why, that's never happened before. Great. Yeah, we can take some of those at the end. Alternatively, we have our office hours. I'll go into that stuff a little bit soon. Yeah, leaving a message on Slack is by far the best way. That way we can look at your code sample, we can share code corrections. I've never tried dictating Python. I have no idea how I would dictate syntax highlighting, except maybe putting on a silly voice. That would be some avant-garde theater right there. Okay, kicking off in 2 minutes, waiting for the rooms to fill up. Hey, Vamsi, do you want to leave a message saying, hey? Oh, missing HTML from Docker image. That sounds like a hello world problem to me. Yeah, Slack's the best place to leave that stuff. If you're not already on our Slack, join us at slack.jina.ai. If you're not on our Slack, then I guess you found out about us some other way. We'll have a poll at the end, so let us know where you found out about us. Yeah, we don't have many folks from Jina joining us today. It's a public holiday here in Berlin for Women's Day. Public holiday for everyone. So some of us poor sods are actually still at work, but...
Better to be on holiday.
Sorry? It's hard, I know, it's a tough life.
It's better to be on holiday. I'd like to also.
Yeah, I did think of coming to work in my pajamas, but I was surprised when other people were in the office. So thank God I didn't come to work in my pajamas. That would have been something. Cool. All right. Let's get this show on the road. So hey everyone, thanks so much for joining us once again for Jina AI's Engineering All Hands. It's great to see a load of new names. We're a little emptier than usual today because it's a public holiday here in Berlin for Women's Day. So a few things before we kick off. I'd like to welcome our speakers, Raphael and Akshat. They're going to speak about vehicle search using Jina and audio search using Jina, respectively. Before we go into all of that, just a few things. We are going to have a quick poll afterwards. It'll pop up in your web browser after the webinar. So we'd love it if you could help us out there. It's just 2 or 3 simple questions to help us work out how to make these engineering all hands kick more butt. So you'll enjoy them more in future. We have got some other events coming up towards the end of the month. I believe the last Thursday, we have our office hours. So if you're having trouble with Jina or you want to discuss your use case or get support, you can come to us there. So that is more of a Zoom meeting than a Zoom webinar. So everyone can just pipe up, say whatever you need to say, get support, and yeah, and have a beer as well if you like. God knows we will. We will also look at holding an offline event, one of our Jina and Tonic events in Berlin. Keep an eye on our Slack for details on that. We haven't set a firm date or a firm agenda yet, but it'll likely be something workshop-y where you're going to build your own search engine for memes or fashion or, I don't know, NFTs, or tell us what you want and we'll see what we can do. I'm not sure we can help you find love, but we can help you find any other kind of data. We've also set up a couple of new repos under the Jina AI org. One of them is the FAQ. So if you have a Q you want to A, that's the place to do it. Leave it in our issues. Or yeah, if you have an A for a Q, I'm getting myself confused. If you want to ask a question, ask it there. And if you want to answer a question, you can answer it there. And we've also got a new Good First Issues repo as well. So the Jina AI ecosystem is pretty big. There are lots of things we can do to improve it that aren't directly related to the core project. The core project being Jina, Docker, fine-tuner. So if you see or you think of cool ways you can improve Jina, like writing a React.js component to interact with Jina more effectively via web-based front ends, leave it in the Good First Issues, because we really want more ideas. And if you see a cool Good First Issue you want to be involved with, jump right in. Let us know, we'll assign it to you. If you do a great job, we'll send you cool swag. And we've got a few things on there right now. Actually, why don't I share my screen? So if we go to Good First Issues, yeah, we've got a whole bunch of stuff you can do. React components, Vue components, helping us migrate some of our examples, build things using Jina. We've got built-in NFT search engine right there as well, for those of you who are into that kind of thing. Yeah, that is pretty much it from me. We'll be sharing links to these on the Zoom chat. So check right there. And yep, let me check my notes. All right, I'm going to hand it over to Joan briefly. He is going to talk about what's new in the Jina ecosystem, and then we'll move straight on to the main talks of the day. All right, let's go.
Hello, guys. So my idea is to share some of the new things that have been happening in the last weeks. It's hard for me to say when things happen because we move so fast. But what I want to talk about is about the new document stores for Docker. And then we added some better explanation about how Docker and Jina core repo relate to each other, and to clarify this for those part of the community that may not have a clear view of which problem should be tackled from which angle. And then also we are going to take a deeper look at a cool feature that was released with 3.0, that is the Sandbox, and a cool demo that we created with it. Okay, first of all, we want to, the biggest new is this document store extension that we added to Docker. So Docker, as you all know, this is the package that supports this document array and document types. And all these document types, you all should say that they are your favorite unstructured data for data structure for unstructured data. Otherwise, you are not in the right place. But this comes with a little bit of a limitation. So document array is kind of a list-like object, and it lives in memory. So in order to this can support most of the use cases for data scientists and people playing around, but people might have some needs of persisting the data and on a backend, on a database, or to add extension for more efficient nearest neighbor search. And therefore, what Jina is doing right now is we adding these document stores extensions. So these document stores extensions they are extensions that are added to the document array, but they are almost transparent to the user. So document array main interfaces are still equivalent, but you can work with document arrays almost as if they were living in memory. For instance, some extensions that we have right now added is this SQLite. This SQLite is you have your document array as you have them in memory, you might have them backed in an SQLite database. With that, you can add much more documents or bigger documents than your memory can fit. And this with a simple usage, just adding some storage and some configuration, and like this, you are good to go, and you would likely not even feel that your documents don't fit, are not in memory. There are some limitations, but for most of the use cases, I think are good to go. So for instance, modifications, of course, you cannot modify in the same way as in a list you would do as in a Pythonic list, but all of these things are quite clear. Other document storages that we are quite proud of is this Weaviate and Quadrant. So Weaviate and Quadrant are vector databases that we have added them because they provide something that document array in memory don't provide, is the data persistence, and then you can very easily use the benefits of using any of these vector databases that can provide potentially better and faster retrieval. And for instance, another one that we have is ANN Lite. In this case, you don't have any external services that hold the data, but you can enjoy this NN Lite that is our approximate nearest neighbors library, and you can, for free, as I repeat, almost feeling no pain, enjoy the benefits of the effective search algorithms that it comes with. And for those who might even be more advanced and they want to enjoy the benefits of this structure, but they want to do some change or on how the backend, how the data is persisted, or in some behavior as the match or find method, we have here a guide on how to add your own document store. Imagine you want to, instead of SQLite, you might want to work with Redis or something. By following this set of rules and overwriting set of methods, you can enjoy these benefits as any of these do. So this is one of the biggest news, and this puts document array in the center of all the neural search ecosystem. Then another thing that we added is this clarification of how does doc array integrate with Jina, and this is something that we've seen that a lot of people struggle with understanding. So here is a picture that clarifies a lot the journey that we expect users to take. So as a starting point, you don't know what is Jina, what is doc array, but you've heard of us. So what we think is that doc array is the tool that should help you at the first stage of your process. It's going to help you to build local prototypes, to work, to iterate fast as a monolith, and it will help you to fast prototype. And then whenever you are ready, you would be able to modularize and scale it and serve it as a service. Then you move from doc array to Jina, keeping the doc array knowledge and all the doc array capabilities that you have already. So what is the point? First, you have to take if there are no executors in the Jina Hub, the point is that you have to write all your logic that you have been writing in your local experiment. You have to write your logic as an executor. Then you put it in flows and you let Jina use it for what for? So to serve it in a client-server architecture, to scale it out, to share reuse, to deploy in a cloud or in Kubernetes, for instance. And this is a good link for me to show the last part of the things that I want to show today. I want to show this Sandbox feature. So Sandbox Feature is a capability that we added recently in 3.0 that allows you to let Jina run the code for you. So imagine you have an executor that you want to try, an executor from the hub that you want to try. Instead of downloading the image and running it yourself, maybe hitting some problems, or maybe you don't have the capacity to run it because their machine is small, you can wrap it in a flow by calling the Jina Hub plus Sandbox. And what it does is it tells Jina infrastructure to serve it for you, and it will not run locally. It will run somewhere in the cloud. Like this, you can benefit from these features, and you can try it out and do some quick prototyping without the pain of needing to run this locally. And let's see, what do we do? This Cocky TTS, this stands for text to speech. So what happened here? So Han here created this nice executor repo that pretended to have something that transforms a text in a document a text in a document into some speech. So it created this executor. As you see, he used some of the nice features of document array and document to create this logic.
Joan, can you bump up your font size?
Oh, yeah. Well, so he wrapped his logic into this executor and he pushed it to the hub. And therefore, everyone in the community can just write a flow like this and benefit from this. And let's see. Here, I just did the effort to do it for us. So I created a flow. It's accessible via this local. So with a client, I can send the text and it will be transformed to speech. So I say, what are you up to? So let's see, how do we send it? It's a little bit of expensive. We are not using any GPU machine or anything, so it's a little bit expensive executor. I'm sure it could be optimized from this site, but what we get is a nice experience of how we convert this text to a text without running anything locally and just enjoying the benefits of Sandbox.
Hey community, what are you up to?
Did my audio sharing work? Good. So this is it. This is everything that I wanted to share with you, with the community today.
Very cool. And yeah, anyone can go there to this notebook and get Jina to say whatever you want Jina to say. But hey, keep it clean, people. They're not going to keep it clean, are they? All right. Yeah, thanks, Joan. And yeah, over to whoever is next. Is it Raphael or Akshat?
So I'm going to start. We decided that I will start. So okay, do you see my screen? Yes. Okay. So nice to meet you. My name is Raphael. So I'm a PhD student in France at Toulouse. And as part of my PhD, I'm working on natural language processing. So also I'm working for the artificial intelligence team of Renault, the car constructor. And I'm developing Python script dedicated to neural search as part of my thesis. So today I'd like to create. I'd like that we create a demo together dedicated to car search. So this demo would have two distinct components. First, a textual search dedicated to retrieve cars, for example. So here, Nissan would yield Nissan cars, and a second component which would allow us to click on those images to get the most similar vehicles. So the first component would be made with Search. It's a tool that it's an open source tool that I created. And the second component, when you click on the picture to get the most similar cars, would be made using Jina. So, so why using two distinct tools for a single pipeline of neural search? So I'd like also to show that we can easily integrate Jina in any Python code thanks to its API. And I do think that yes, that we can integrate such Jina easily. So the first step to create this pipeline will to get the data. So I download a dataset on Kaggle with a few cars. So let's check this dataset. So here I'm loading the dataset that I download from Kaggle. Okay. Let's check what it looks like. Documents. Okay, so I downloaded from Kaggle few cards. So for each card, I do have the brand, the model, the year, and some pictures. And as you can see here, I have a folder called sample dedicated to all those pictures. Okay. So the first step is to design this textual search. So to do this, I'm just using Search, and then I will enhance this textual search with Jina. So the first step is just to create a TF-IDF retriever. It will be fine. Okay. So I do have an ID in here in every document. So I will do a search over brand. I will not go especially into the detail on these things. I think, yeah, okay. Here are my documents. So it's simply a function. The thing is simply a function. You will make your query and it will yield the most similar text based on brand, model, and year. Okay, so here I have my function dedicated to match the text. So if I do this thing here, I do retrieve documents dedicated to Ford. So I do have only the ID, so I will map my existing documents. And then here it is. Okay, so now my textual here search bar is ready. I do have a function that yield result for a given query. So now I'm going to enhance. I'm going to create a new field here dedicated to most similar pictures. So for each document, I will get using Jina the most similar vehicles. So to do this, let's first go on the Jina cloud. Okay. Okay. So I'm just going to copy paste the Jina GitHub pages because it works. Okay, so here I'm importing the package that I will need to perform neural search over image. So this function will allow me to load so every pictures and normalize also the pictures. So it's the pre-processing step. Then so I will embed the image. So I will convert the path. So it will here it will load the image. It will normalize the image, and then we will compute an embedding for each image. Okay. And this component, this executor will be dedicated to match the images. Okay. And this thing will be workflow. Okay. Okay. So here we have a complete pipeline with Jina. And then finally, what I need to do is to load all my pictures. So in the folder sample, I do have all the pictures of my documents, and I will load them. So I just have followed the tutorial on the GitHub of Jina. Okay, I have a pre-pros image, embed image, match image, and a flow. And then I will be able to to create an API here using Jina. So I would rather like here to create an HTTP API because I'm more used to. So I will need to define the protocol of my flow here. Okay. Here is my index data, and I just have to run this cell to launch the API. So here, I already, launch the API in another notebook. Maybe I could show you here. Sorry, your screen sharing is paused. Sorry, I'm going to new share. Sorry, hop là. Okay, so I did already start the API because it will need time to pre-compute. So just to show you, here it is. I could do a request, for example.
Raphael, we
Yes.
can't see the. Oh, okay. Yeah, you're in the demo notebook. Yeah.
Yes. Sorry.
Okay. Cool.
I was copy pasting some code. So here is an example of the request to Jina API. So I'm just passing a picture of a car, and it will yield a most similar result. So let's so here we do have both components. Okay, the textual search using Search on GitHub, and the image search using Jina. So let's connect those two things to create an unsaid neural search pipeline. And you will see it's pretty easy thanks to the API. Okay, so do you remember we do have a retriever here? Okay, so now we are going to create a function called enhance. Here, this document is a list, and this function will take as input the documents of the retriever and will enhance thanks to Jina API. So the goal is to show that we can integrate Jina into existing stack. So first, let's create the field data here dedicated to the request. So we will create request automatically. So, so let's create the field data. Okay. I'm creating the field data to make my request. Now I do have my field data, so I can here replace, this thing. So data with a mapping to data. let's check if this thing works. Okay, it seems to work. So now let's enhance our document. Sorry, I do have okay. For document match in zip, okay, so here I'm iterating over both match and documents. So here I will add a new field to my documents, the most similar pictures. Okay, and I will, here it will be equal to, so I will access to the URI, so to the path. I do think it will work. Okay, as you can see, now we have a new field in our retriever. So we manage to retrieve the Ford and the path of the Ford, and also we manage to retrieve the most similar pictures to the Ford. Okay. So let's, since we created every components, I did cheat a bit because I did already create a Streamlight app following this pipeline. And now we can, for example, perform textual search. Okay. Since we using search, we retrieved the most similar vehicles, and then I'm able to click on a picture, sorry, to get the most similar cars. So I do think it's an interesting feature that could be integrated into any application to be able to click over pictures. I think it's fine. So let's click over the Volkswagen here. And yes, it match some cars. Of course, I did not fine-tune the neural network models. And of course, we should fine-tune this model using Jina, Jina fine-tuner, and it would greatly improve the result, because here, let's go back on the API, let's refresh this. And if we, for example, let's take, if we take Aston Martin, for example, here there is a background. So if we click on this picture, our ResNet will match the background rather than the car. Here we would like to match the car. So to improve this app, we should, of course, fine-tune the deep learning models, and also maybe add more fields to retrieve text. Okay, and I think that's all. You'd like to see also Benz. Okay, let's check. So here are some Mercedes. So we could, yes, of course, also perform a neural search just as Benz the last year. Okay, and we can get the most similar pictures. So yes, since we did not fine-tune the neural networks, yes, actually, it may not be very convincing, but we could get, I'm sure, a very good result. Okay, here are some models that some cars that look like Mercedes. So this BMW seems BMW seems similar. And I think, yes, I think that's all. I was a bit too long. And thank you.
Thank you, Raphael, and not too long at all. That was really, really informative. And it made me think of a book that I really like, that some of you may know, by Janelle Shane, called You Look Like the Thing and I Love You. I'll share a link in the chat, and it's all about how AI doesn't always work as you think it would. And this misclassification problem is really common. Like it's trying to recognize pictures of fish, but it's been trained on people holding fish. So it's not trained on fish. The features it detected were fingers instead. And it's such a fun book. Great.
Actually, I did enjoy to play with Jina, and thanks to its API, I do think it's easy to integrate into existing stack. I do think you don't need to rewrite to recreate all the stack to integrate Jina. You can just add a new feature, and it works fine.
Yep, that's how we get them in. It's a gateway drug. Cool. If you have any questions for Raphael or for any of us, drop them in the Q&A down at the bottom of the Zoom call, or put them into the chat. I'm not sure which way I should be pointing on YouTube. All right. Very cool. Thanks again, Raphael, and over to you, Akshat.
Yeah, sure.
Oh, we've got a question already.
Okay.
Is it possible to convert face identity application with fine-tuner? You mean to train a facial recognition model? I would say that, and Joan can probably answer better than I can, but with fine-tuner, you can fine-tune any model that use PyTorch, Keras, or Paddle.
So, yeah, I think all the losses involved in that should be supported, I think.
Yeah, there is a specific model called FaceNet. I'm not sure what that's based on. So yeah, and in my experience, it wasn't great, but your mileage may vary. And it depends what you want to do. Like detecting a face is very different from recognizing a face. And I think I was building a demo of some facial search, but yeah, facial recognition is a dicey subject. If you search Detroit facial recognition failure, you'll see how it's been used in police enforcement, and it was really bad, like a 2% success rate. But depending on your use case, it may work better. For example, if you have a whole bunch of your personal photos, you and your 10 best mates, and you want to identify out of 10 which people are in which photo, I think it would work a lot better than if you're trying to build a criminal database. Yeah. So yeah, if there are any more questions, dump them in the chat or in the Q&A. And yeah, over to you, Akshat.
Yeah, thank you. Let me share my screen. I hope my screen is visible now.
Yep, red and clear.
Yeah. So first of all, thank you to the Jina community for inviting me over here. And hello all, I am Akshat. I am from India, and currently I'm in my pre-final year in IIIT Hyderabad. And my journey started when I joined a program named Wind of Code 2.0. And thanks to Jyoti, she's a great mentor for giving me the opportunity to work on this awesome project. So we had a list of issues to choose from. So I choose this project named Shazam. So the original link to the issue can be found over here. So the project is all about you can enter an audio and search like which song it is from the present data set. So then I started building my project in a stepwise manner. I first built my backend part, then moved to my frontend part. And the data set that I'm using over here is from Kaggle. So one need to download this data set to use with this project. And yeah, so when my program started, so we started learning about the basics of Jina. So we started learning like what this document is, just a basic data type. Then we moved on to learn like what is executor, and it is just how like Jina processes documents, and flow is basically how.
Sorry, if I could
Are you
just
saying-
jump in here. If I could just jump in here. Oh, there's a bit of an echo. So yeah, you are using Jina 2.2, right?
Yeah, exactly.
Yeah. So for anyone watching this and learning from Akshat's code, awesome. But just be aware that things have changed quite a lot in Jina 3.0. So yeah, there's the disclaimer.
Yeah. So yeah, and then after learning all the basics, I moved to this learning how Jina actually processes audio. So I learned that how Jina actually processes documents and how it stores in the document, and yeah, and then I moved to this another section, which is search similar audios. So it actually sounds much similar to my project, so I was much curious about it. And when I moved to it, I found that okay, like it helped me to learn that how I can actually build my project. So before going through all this, first we can just open this particular link present over here, example audio search. Yeah. Yeah. So first here we are discussed about like we need to segment the audio clips. So the problem is that the whole clip it is so long so that we cannot just express it into a single vector. So what we are doing over here, that we are just splitting that whole clip into small chunks and storing them. And then we are using audio segmenter, which is basically an executor to do the same. And we can find it over here. Then we have that we need to encode our audio. So to encode our audio, we are using this Vijesh model from Google Research. And Vijesh audio encoder is basically at Jina Hub. So those who don't know about Jina Hub is basically a place to host the executors, and everyone can use it. So I have also used it over here. So if I will navigate to this section, so we are going to use all these codes. So just let's copy it. Just let's paste it over here. And then we also have this British audio encoder, and since it is present in Jina Hub, we need to we need to create a flow.yml file so that we can use it, and we need to copy this also. And we are using other executors as well, which we are going to discuss as well. So we just need to make small changes. So we are using I believe the latest version. We had some problem with the version 0.7, and I'm happy to say that like I helped in the Slack community of Jina to fix it. And then we finally need to put everything all together. So So then we are also using simple indexer. So simple indexer, we are using it basically to store both the embedding vectors and meta information. And then we have our matches, which we will be using via this myRanker. So myRanker will help us to find these similar matches for our input query. And but when we have our match, you remember that our audio is present in form of chunks. So at that moment, we need to actually stitch them together. Like we need to merge all the matches at this point. So myRanker, which is present inside over here. So we are using myRanker for that purpose. And finally, we need to put all the things together to make it work. Yeah, but in fact, we can copy it from here. It is present more beautifully. Yeah, so we have almost everything, but we still have not given the data that we will be using. So for that purpose, we need to generate it. So as I told you that we are going to use that Kaggle dataset, and we need to download this journals_version2.csv file, and it has some track IDs, list of track IDs, and we are going to use it. And those track IDs are basically of Spotify. So we are basically using a Spotify dataset. And since we have track ID, we also need to fetch the information for that particular track, like the track itself. So to do so, let's copy this part. Yeah. So basically in this generate data function, we are first checking if our data folder is present or not. If it is present, then we are filling with the new data. And we are using a Spotify client. So for that purpose, we actually need to have some environment variable set. Like we must have this Spotify client ID. I will discuss more about Spotify later, and also this Spotify client secret. And I have given a link over here that how we can obtain both of them. And when we have set both the environment variables, we are good to go. Just let me make more imports. So yeah, I believe I've made all the necessary imports. Oh, we also need this CSV module to pass our CSV file. Yeah, so Spotify, sorry for this typo. Yeah, so since we have all the things over here, so Spotify basically is a library to library for Spotify web API, and it helps to get all the access to the music data. Basically, we can fetch preview URL, not the whole music itself, and because of copyright issues, I believe. And yeah, and we'll be using this library over here. We'll take help of it. So yeah. So we are just iterating over all the track ID that is present in this genres underscore version2.csv, and we are limiting the number of track IDs to just 15 because processing all the data will take some amount of time. So I'm just limiting it to 15, and else there are thousands of track IDs present in that CSV file. So yeah, for that, for each track ID, what we are going to do that we are going to save that song, and to do so, we are going to get the help of this Spotify library. So first, we are creating this object. Actually, we can follow the basic tutorials given over here. I've used the same. Yeah. So from here, and it helped me to get to know like how we can fetch the tracks. So after fetching the track, then I'm doing some error checking and some action. And then after fetching the track, we need to fetch this preview URL because we are going to give it. We are going to store this in our data folder so that we can make we can run query on it. And after doing some checks, we're finally storing it. But you can see that there's special thing out here that I'm storing all the that track with track ID, and it is going to be useful that on. So yeah, I believe our backend is ready. I'm not going to run this because it is going to take some time. So I've already run a older one over here, and we will use this. So our backend is almost ready, and now we can build our client side. On our client side, we actually need we are going to use Streamlit for this. Let's set more. I'm going to copy it from here. So let's try to run it. So yeah. So in the meanwhile, we can build this thing more. So what we are going to do next, that we need to upload our file. So in that case, we need to upload our file and get matches, right? So we are going to do that much part over here. So I'm not going to put all the code over here. So give me a minute. Yeah. So I'm going to create a helper.py file, and in that I'm going to put this rest of the code. So from helper matches. Yeah. So over here we can put the rest of the code, and you can just copy this whole thing. So over here, what we are going to do, that we have this upload file, and it is present in the form of bytes. So first we need to store it, because if you will check the documentation over here, I believe like the documentation was key in throughout my whole journey. It is like really helpful. So it is mentioned over here that we need to query to the backend in this particular format. So and over there it is mentioned that we need to pass the path to whatever audio that we want to query on. So in that case, I'm just storing that particular byte, all the bytes data in this audio.mp3 file. And since our backend is running on this 45,678, as we can see it from here. It is mentioned flow.yml, and we are going to use this particular endpoint to search for our particular input, and we are going to pass the whole data in format of JSON. So we are defining headers over here, and we are running our backend on localhost. So after obtaining this path from here, we are just passing this data over here, making that post request, and obtaining that content from here, and returning matches from it. So if any exception occurs, then we are just returning this empty list. So our helper.py file is ready, kit matches is ready. So we have matches over here. Now we need to loop over them and need to present the whole data. So, but there's a problem. The problem is that what we are returning over here is just a path of the file, like path of the found matches. So what should we do? That what I'm going to that I'm going to fetch the particular track of the obtained track ID. So let me just show you what do I mean. Just let's copy the rest of the code. Yeah, we need to make more imports. Yeah, do we need to make any more imports? Yeah, we need to import OS module. I believe everything is okay. Okay. We also need so at this point, what is going on that we have match URI, and match in match URI we have our data something present as data like path to our matches, like something like this track ID. It is basically a path and .mp3. So at this point, what do we need to do? That we have only we can use that particular file, but we don't have the name of the song and images related to it. So to tackle that, what I'm going that I'm going to extract this track ID from here. So I'm using this particular get track ID function. So let's put that quickly. So we have a relative path and we can return system value. Yeah, hopefully I've put no. Okay, no, current absolute path is not defined, so we can just copy it over here. Yeah, so over here we have extracted this track ID, and we are again using our Spotify library to fetch that particular track, and we are doing some checks over here, and after checking all those things, we are displaying the name of the track or song that we have found, and it's external URLs. So because of copyright issues, using Spotify library, we can only fetch a preview URL, which is of 30 seconds. And using external URLs, we can just literally head over to Spotify and listen to the full song. And we have images over here. And that's what I'm displaying over here. Yeah. So our client is running, and we can head over here. Yeah, just refresh it. It's running, yeah. So let's try to put some file. So I don't have any other audio files. In fact, like we should query using any other audio file, but right now I'm using the data set that I have created over here. So the first song must be the song that I have given as input, but we will also get 5 other songs, and which must be close to this particular song. It is running. It can just be maybe I've encountered some bugs. Okay.
You have a link to your repo for a live demo running on Akshat.
Yeah.
Live demo running on Akshat.
Yeah, I have linked to my repo, and over here I have also given also pasted the video over here.
Cool. Yeah. Oh, very cool. Could you post that to the chat? Just make sure that it's posted to everyone, not to hosts and panelists.
Yeah, sure.
Yeah, as fun as debugging is, I'm not sure anyone wants to watch it.
Yeah, sure. So it's actually issue related to path. So yeah, and oops, let me share it to everyone. Yeah, and the link should be visible to everyone.
Awesome. Yeah. And yeah, I actually tried running this on my own machine. It does work. So, or it did when I tried. So yeah, anyone who wants to test it out, just go to the link and yeah, get it going on your machine. Do we have any questions for Akshat? Okay, nothing so far. Anything from the YouTube? Nothing from the YouTube. Okay. All right. Well, in that case, we've gone over the top of the hour. So yeah, thanks for rocking up, everyone. Stay tuned to our Slack. You can join us at slack.jina.ai. We've got a lot more upcoming events. And Raphael, Akshat, how can people follow you? Do you have Twitter, or what's the best way?
I'm not active. I'm only a reader on Twitter, but on GitHub, just follow me on GitHub, and you will see my pull request and commits.
Perfect. If you could post your GitHub repos marked to everyone, we can all go and follow you.
Of course.
Yeah.
And yeah, we'll be sharing the video of this on our YouTube in the next few days. It'll all be cleaned up and nice. And yeah, stay tuned, like I said, for more events. And we'll just stay on the line so everyone can post everything else they want to post. Okay, I hear no more typing. So thanks again, everyone. And yeah, we'll see you at the next engineering all hands. Well, no, we'll see you at the office hours because you all are going to be there on the last Thursday of the month. All right. Bye, everyone.
See you.
Have a great day.
Bye-bye.
Bye.
Thank you again.
Thanks.